Hello and welcome to the Air Products webinar. My name is Neil Hansford and I'm the Air Products Grinding and Cryogenic Application Specialist. Today I'll be talking about choosing the best grinding technology and cooling method for your product. Air Products is a global atmospheric process and specialty gas, performance material, equipment and service provider. Our corporate vision ensures we remain customer focused whilst maintaining our integrity, respect for others and sustainability. With over 18,000 employees worldwide, Air Products is renowned for our innovative culture and operational excellence. For over 70 years, Air Products have been successfully serving many global markets including industrial, energy, technology and healthcare, and we have over 40 years experience, data and expertise in grinding technology. There are many different types of grinding action. Each action can provide a difference in particle shape and size. These grinding actions include impact, where size reduction occurs by the force of the material being hit by the grinding tools. Attrition, where size reduction occurs by the material being forced between two surfaces. Shear, where size reduction occurs with a cutting action. And compression, where the material is compressed to obtain a size reduction. There are many different grinding technologies developed for many different types of material and particle size requirements. These include ball mills, hammer mills, knife mills, pin mills, attrition mills, turbo, and jet mills. The next few slides will show some of the common differences between some of these types of grinding technologies. Ball mills are often used to grind materials to ultra-fine particle sizes. A ball mill is a rotating cylinder filled with the media to be ground, along with a grinding media such as a ceramic or steel ball which provides the grinding action. They can provide a grinding and mixing action during the process. Ball mills can provide high volumes of material but are often very large and can use high levels of energy. Some examples of products they can grind are hard minerals, ores and alloys. Hammer mills are commonly used for high throughputs of fairly coarse materials. A hammer mill is essentially a steel drum containing a rotating shaft on which hammers are mounted. These hammers provide the grinding action. They can be a very robust technology but can also use high amounts of energy. Hammer mills are often used for food, plastics and recycling applications. Knife mills can provide a very clean grind or cut of material whilst using a relatively low power consumption. A knife mill normally consists of fixed or rotating knives which provide the grinding and cutting action. They often provide fairly high throughputs but at a coarse particle size. By the nature of their design, knife mills can have high wear rates of the grinding tools and commonly are used for grinding rubbers, textiles and recycling applications. Pin mills can have either one or two rotating discs with inlaid pins that provide the grinding action. They can provide a fine grind of material but can suffer from high wear rates and the grinding tools and pins due to the design of the mill. Often pin mills are used for grinding spices, chemicals and thermoplastic materials. Attrition mills can be a low-cost and simple grinding technology that can provide fine grind, but are often at low throughput rates. An attrition mill normally consists of two serrated discs which the material to be ground is fed into. They can suffer from heat buildup between the attrition discs due to low airflows. Attrition mills are often used to grind rotational molding type plastics. Jet mills can often come in two different designs, spiral jet or the newer fluidized bed type which can also contain an internal classifier. Both designs can provide ultrafine particle sizes but at very low throughputs. Often these mills are used in the pharmaceutical industry where sub 10 micron particle sizes are the norm. The turbo mill is a high-volume, fine-grind technology. It can be easily adjusted to suit variable particle size requirements and has a relatively low power consumption. Often used in thermoplastic coatings, spice or rubber grinding, the turbo mill can suit many different materials and applications. This chart shows where the different grinding technologies previously mentioned fit with regards to particle size and throughput rate. All the grinding technologies can be adjusted to provide varied performance, but this slide provides some basic guidelines. During the grinding process, all technologies develop heat due to the frictional energy created from the electrical power required to drive the mill. As a general rule, the tougher the material to be ground and the finer the particle size required, the more heat that is produced that needs to be removed. The heat created in the grinding process can cause many issues, including reduced particle uniformity, higher wear rates, coarser particle size, product degradation, and reduced throughputs. To solve the heat problem, there are many ways to cool or remove the heat generated during the grinding process. The most commonly used method of heat removal is to use air. High volumes of air flow through the grinding system to remove the heat from the grinding area and also to move the material to the next stage of the process. This is the lowest cost method and is often used in coarse grinding applications. A downside of using air to cool the grinding process is that it has a limited cooling capacity and can therefore limit the particle size the grinding system can produce. Another often used cooling method is to use a water or water-air mix to cool the material. This can either be used to cool the mill or the material using an external water jacket, or to mix with the material feed going into the mill, or both. Often water-cooled mills are used in cement production or rubber grinding. The water cooling option gives a low-cost cooling and can often help grinding tough materials by softening them prior to grinding. However, water cooling is not suitable for all materials and can require a second stage to dry the material. Liquid nitrogen can provide a very effective heat-removing method. With a temperature of -196 centigrade, it has a very high cooling capacity and can therefore cool even the hottest grinding process. The liquid nitrogen is often injected into mill inlet to mix with the cooling air to increase the cooling capacity and to pre-cool the material to be ground. Typically, liquid nitrogen is used to increase the throughput of an existing air-cooled grinding system. The additional cooling energy available from the liquid nitrogen allows the customer to increase the material feed rate and therefore gain an increase in throughputs. The nitrogen will give an increased operating cost, but this is often outweighed by the production increase and a material quality improvement. Cryogenic grinding offers cooling of the material to be ground prior to it being fed into the mill. This method often uses a cooling conveyor where liquid nitrogen is injected to cool the material to its glass transitional temperature. This is the temperature where the material has the same brittleness as glass and is therefore easy to break in the grinding process. Heat removal with cryogenics is often used to grind tough materials like thermoplastics, spices and resins to fine particle sizes. Often a particle quality improvement is gained along with a throughput and yield improvement. Cryogenic grinding is commonly used where grinding tough materials to very fine particle sizes, as shown on this table. The tougher and finer the material requirement, the more likely cryogenics are required. With so many different grinding technologies and techniques, it can be very difficult to decide which is the best for your needs. There is no one perfect mill or cooling method for all materials or particle sizes, but at Air Products we can give you the information and technology you need to find your best solution. Air Products can design and supply the right cryogenic grinding system for your needs. We can supply you with a nitrogen inerting system to ensure your sensitive or explosive materials are protected. We can supply a nitrogen temperature control system to ensure you increase your throughputs and profitability. And we can supply a full cryogenic grinding system to ensure you can achieve your desired particle size requirements. Air Products have designed the latest in cryogenic grinding technology, the PolarFit ultrafine grinding mill. This mill is exclusively available through Air Products and is built at our own engineering facilities. Using cutting-edge technology, Air Products have developed a turbo mill that can outperform other grinding technologies in its class. The mill can be adjusted for speed, grinding gap and temperature, all of which provide a flexibility required to give you the best grinding technology solution. Air Products can also design and supply a complete turnkey solution for your size reduction requirements. This animation shows an Air Products PolarFit system designed, built and installed by Air Products. Typically, our installations are turnkey solutions including material feed systems, cryogenic cooling conveyors, grinding technology, sieving equipment, air classification technology, and full control systems. The key benefits of the PolarFit ultrafine grinding mill include ultrafine particle size, flexibility to suit your material specifications, reduced nitrogen usage, and combined grinding methods including particle-particle collision, impact, and attrition. This slide shows an example of the particle size distribution achieved on the pin, hammer, and air products grinding mill technologies. The different grinding technologies provide varied particle sizes, with the ultrafine grinding mill giving the finest grind. The key advantages of the PolarFit ultrafine grinding mill are reduced wear rates, improved reliability, more uniform particle size distribution, and easy maintenance. So to summarize, the PolarFit ultrafine grinding mill can provide you with the benefits you need to obtain an efficient, reliable, and cutting-edge cryogenic grinding system. So why not test your materials on our grinding technology at one of our PolarFit testing facilities and get expert advice on the right solution for you? If you'd like to see a video with more information on our PolarFit ultrafine grinding mill, then please fill in the questionnaire at the end of this webinar. Thank you for your time today. If you have any questions, then please contact me on the email address shown.